Hello, algebra students. This lesson is going to be on how you can solve quadratic equations by factoring. Before we get into the lesson, we've got our review question. Go ahead, pause the video, and solve the system of equations. All right, in order to solve this system, you would want to use substitution since we know y equals 3x plus 5. So you would substitute all of that for y. When you do that, that gives you 2x plus 3 times what y is. Because y is multiple terms, you want to make sure you're using parentheses. So 3 times 3x plus 5. And then that would equal 4. When you solve this equation here, you get x equals -1. Once you've got one of your variables, you can substitute it into either of the equations. If you substitute it here, you get 3 times -1, which is -3, and -3 plus 5 gives you 2 for y. So that final point would be the point -1, 2, since y is 2. And that would be the solution point for the system. Now that your brains are warmed up, we'll jump into today's lesson, which is on solving quadratic equations by factoring. We have been talking about factoring for about a week now, and one of the reasons why you want to know how to factor different expressions is because you can use that to help you solve quadratic equations. Similar to when we were solving systems of equations, solving quadratic equations, there are multiple methods you can use to solve them. Factoring is just one of the methods, but it's a good place to start. So that's what we'll start with today. Before we get into solving quadratic equations by factoring, I have got a question. And the question is, if I am thinking of a number, let's say the number is x, and I tell you x squared equals 25, what does x equal? Now, pretty quickly, people, when I give them this information, they say, well, x is the number 5. I'll ask, well, how do you know? And they say, because x squared, well, if x is 5, 5 squared equals 25. And I say, correct, x is 5. But what if I told you there is another number x could be? People are usually stumped for a moment because you're thinking, well, 4 squared isn't 25, 6 squared isn't 25. What's another number squared that gives you 25? Think about all the numbers we've got in math, not just like the positive numbers you count by, but all the numbers. The other number x could be here is, do you know it? -5. -5 squared is also 25. -5 squared means -5 times -5, which also gives you 25. Now, the reason I start off with this is a quadratic equation. It's got x squared in it. It's a pretty simple quadratic equation. There's not too much going on in it, but it's a great example of why with quadratic equations always have two possible answers. It's pretty easy to see from this quadratic equation that there are two different numbers you could make x. You could have x be equal to 5 or x be equal to -5. This is going to be a theme in all the equations we're solving today. We are solving quadratic equations, and for each equation we're solving, there is a possibility of having two answers, just like this. So similar to this, our answers when x can be two different numbers, you could write it like this. You could say x equals 5 or x equals -5, x equals 5 or -5. But there's a possibility of having two different numbers for our variable, which is different than what we're used to. We're used to there only being one number that the variable is. The other thing before we get started with solving quadratic equations is we're familiar with the quadratic expressions being the form ax squared plus bx plus c. If it's a quadratic equation, there's a second part to that. If you have a quadratic equation, you want it to be in the form ax squared plus bx plus c equals 0. it must equal 0, and the reason for that is you just want everything on one side of the equation so that you can see what all three of these terms are, the ax squared, the bx, and the c. So you're just moving everything to one side. Now that we are all ready to go, we'll start with this first question here. So I have got the quadratic equation, x squared minus 5x minus 24 equals 0. This is an example of a quadratic equation. It's in that form, ax squared plus bx plus c, except now it's an equation. Remember, our first thing we said was we want to make sure our quadratic equation is equal to 0. That's always your first step. Here it is already equal to 0. That's awesome. Do you think that's always going to be the case? Hopefully you're saying no. And if you are saying no, you're correct. Lots of times there might be some other things over here on this side. And our first step would be to get that equation equal to 0. This case, though, we're lucky because it already is equal to 0. The method we're using today is solving by factoring. So our next step is let's factor this quadratic equation. We spent a lot of time learning how to factor this. So we're going to utilize all that information and factor this side of our equation. I would encourage you to pause the video now and see if you can factor this expression. Well, it's a quadratic, so I know it's going to factor into two sets of parentheses. And because there's no coefficient, there's no number in front of x squared, means it's one of the easier ones to factor. It means I can go ahead and write the x times x, since that's x times x gives us that x squared. And then the last part of this would be finding two pairs of numbers that multiply to 24, or rather negative 24, and combine to give you negative 5. Those two numbers are going to be 8 and 3, since 8 times 3 gives you 24. And if you subtract, you could get the 5. To get a negative 5 out of it, we would need that 8 to be negative and that 3 to be positive. So just a quick review on how we're factoring quadratics. Now, the difference between this problem here and what we've been doing in the past is it's an equation. So I'm going to go ahead and keep that equal to 0 over there. Now, the reason we wanted to factor it is because you can use this to help you solve the equation. Taking a break from this quadratic equation for a moment, think of a different problem. If I told you I am thinking of two numbers, and those two numbers multiply together to equal 0, do you know what my two numbers are? Well, you might not know one of them. One of them is a question mark, but you know the other one has to be equal to 0. If you have two things that are multiplying together to give you 0, one of them is going to have to be 0. This other one could be a 10, 100, 5,000, but one of those numbers could be 0. And of course, the 0 could be here or the 0 could be here. It doesn't matter. But for them to equal 0, one of them has to equal 0. We are using that fact in math to help us finish solving this equation. This is saying the same thing as this problem up here. We've got this times this equals 0. For that to be true, it means one of these parentheses has to have a 0. It means either 8 minus, I said 8, x minus 8 equals 0, or it means x plus 3 equals 0. Just like up here where we said one of those two things has to be 0, we're saying the same thing here. Now, once we have done that, that has changed this one equation here into two different equations. So the last part to this, if I'm trying to tell you what x equals, it would be solving these two equations. Here to solve this equation, it's one of those quick one-step equations. You would want to add 8 on both sides, and you get x equals 8. And then for our other equation, you would want to subtract 3 on both sides to cancel out that plus 3, and that would give you x equals negative 3. So I'm just going to say comma negative 3. Remember earlier we said that when you're solving a quadratic equation, there's a possibility of having two answers. Here are our two answers. We're saying that in order for this left side of the equation to equal 0, x could either be a positive 8 or x could be a negative 3. Now this fact here only works when it's equal to 0. So that's the other reason why we always want our quadratic equations to equal 0. If it's equals x, if it were to equal 10, it doesn't mean one of these things here is 10, right? It only is true for 0. So that's the other reason why we always want to start with it equal to 0. It's because you're using this math fact that says two things multiplied together equal 0, then one of them would have to equal 0. Now, just like with any equations, systems of equations, quadratic equations are the same. You can check your answers. You probably know how we could check them. You can check by substituting to make sure that they're true. So because there's two different answers here, in order to check both of them, you would have to substitute both of them. I'm just going to show the 8 as an example. If I were to substitute 8 for x, I'm going to just write it right on top of that. 8 squared gives you 64. Don't be fooled by the fact that it looks like minus 58. That's 5 times x, so 5 times 8. 5 times 8 gives us 40. So from these two, we get 64 minus 40, which gives you 24. 24 minus 24 gives you 0. That's what we want to see. If you were to substitute that -3 in, you would get the same thing, that both sides equal 0. Now, this is one example of how we solve by factoring. The part that can change up is how you factor. We saw in the past week, there are a lot of different ways you can factor expressions. We reviewed how you factor different expressions yesterday. So if you missed that lesson, make sure you watch that first, because it was a good opportunity to review all these different factoring methods we learned. But it's this line here that could switch up. But what they're all going to have in common is using this fact of two things multiplied together equal 0. That means we set them each equal to 0 and then finish solving. So I'm going to erase this and move us on to two more practice problems. This one here, what's the first thing we want to do? Well, it's already equal to 0, so it means the first thing we need to do is factor this expression here. How are we going to factor this? Now notice this one here looks different than that last problem. This right here, I would want to start off by using GCF to factor. So I'm looking at my two terms here and asking myself, what factors do they have in common? Well, 15 and 5 both have a GCF of 5. And then for p squared and p, they both have the variable p in common. When you factor with GCF, you only have one set of parentheses. In those parentheses, they're going to be what I need to multiply 5p by to get these two terms. 5 times 3 gives me the 15, and p times p gives me p squared. And then for the second part, I'll copy my minus sign. 5 times 1 gives me 5, and p times, I don't need any more p's to get to the p, so we just get 5p times 3p minus 1 equals 0. Now remember, I'm trying to solve for p. What's my next step going to be? That next step, just like before, is setting each part equal to 0. Now this time, sometimes students struggle a little bit to see what we're setting equal to 0. It might help if I put parentheses around this, but you're saying the 5p, this part here, times 3p minus 1 equals 0. So using that same rule as before, if this times this equals 0, means one of these parts here had to equal 0. Either 5p equals 0 or the 3p minus 1 equals 0. I was trying to use this strategy of writing as I filmed instead of animating all of the stuff to pop up, but I don't know if I like it. Once you set each part equal to 0, what's our last thing we're going to do? Solve these equations, of course. When we solve this equation here, you need to get rid of that 5 by dividing both sides by 5. 0 divided by 5 gives you 0. So for this first one here, we get pi. P equals 0. For the second equation here, It is a two-step equation, so you're going to have to start off by adding 1 on both sides. If you do that, you get 3p equals 1. And then your last step, if we're trying to get p by itself, that means I need to get rid of this 3 here by dividing both sides by 3. When you do that, be real careful. What does p equal? P equals 1 divided by 3. You cannot divide 1 by 3. That is a fraction right there. So we get p equals 1/3. Sometimes people make a mistake and say that this equals 3. For our final answer, we get p equals 0 or p equals 1/3. Remember, you could always check these if you wanted to. For example, if I put 0 here, 0 squared is 0, times 15 is 0, so we get one big 0 here. 5 times 0 is 0, so we get another big 0 here, and 0 minus 0 is 0, for example. You could also check the 1/3 if you wanted. It gets a little more fun, but it'll still give you a true statement. It'll show that both sides equal 0. We got one last one here. If you're feeling good about these, I encourage you, go ahead, pause the video, and see if you can do this last example problem on your own. All right. It's going to start off the same way, where we want to start off by factoring. I think this one here is the trickiest one to factor. It is a quadratic expression that has a coefficient. What does that coefficient mean we need to do? It means we need to multiply our 6 times 12, which gives us 72, and then find a pair of numbers that multiply to 72 that can combine to this middle term here. That pair of numbers that you want to use that multiply to 72 that can combine to give you a 1 is 8 and 9. 8 times 9 gives you 72, and if you subtract them, you can get a 1. So when we find that pair of numbers, remember we use that pair of numbers to rewrite this middle term here. That 6c squared stays the same. For that plus c, it's going to become plus 9c. And then minus 8c. I'm using that 9 and 8 that we found earlier and using those numbers to rewrite the c. That minus 12 stays there. And then we get equals 0. Remember what comes next? Next we use, I'm going to change the color, greatest common factor to factor the first two terms and the second two terms. When I factor the first two terms, our GCF is 3c. And then we find what we need to multiply that by to get this. That would be 2c for the first term and then plus a 3 for that second term to get our 9c. We do it again here. Remember, if that first term is negative, which it is, our GCF is negative. The greatest common factor of 8 and 12 is 4. And then inside our parentheses, we would need to multiply a negative 4 by 2c to get that negative 8c and multiply it by a positive 3 because negative 4 times positive 3 gives me that negative 12. Our last step is because they have a common factor of 2c plus 3. I can pull that out. And then in our second set of parentheses is what's left over. What's left over is going to be a 3c from that first part and then a minus 4 from the second part. And then remember that is, I've just been copying down that equals 0 the whole time. So that equals 0. Once we do that, we're kind of up to this part here now. We're going to set each part equal to 0. So we've got our 2c plus 3 equals 0. And we've got 3c minus 4 equals 0. If you didn't already try this, see if you can finish it up now and find those answers. Our final answer, this first one here would give you the answer c can equal negative 3/2. And for that second equation, we get c can equal 4/3. So we could say c equals negative 3/2 or 4/3. Remember, it's okay for the variables to equal fractions. Sometimes people don't like when they equal fractions or stress when they equal fractions, but it's completely okay. So these were 3 examples. Hopefully you see the overall steps are the same we're following. It's really just this first step here, this factoring, that can change up a little bit. I'm going to clean all this up and give you your 2 you're going to try. For this first one here, when you factor it, you should have y minus 4 times y minus 4 equals 0. If you solve both of those equations, you get y equals 4 or y equals 4. That's the same number, so we don't need to say it twice. Your final answer would just be y equals 4. Remember how we worded it earlier. We said quadratic equations have 2 possible answers. The reason I'm using that word possible is because it's not always going to be 2 answers. This is an example of a problem that only had one, and that one is just y equals 4. For this one here, this is factoring a perfect square. I can see that there's a square root of 9, a square root of 25, so it helps me factor it. It just would be 3b minus 5, and then 3b plus 5. When you solve this equation, you're going to get b equals 5/3 or b equals negative 5/3. Moving along, there are 2 last problems we have to look at. Starting with this one here, we are going to solve the equation x squared minus 11x minus 20 equals 4 minus x. What do you think we need to do first in order to solve this equation? Well, thinking about how this equation compares to the others, it looks really different, as does this one. And part of the reason it looks so different is because all of our equations before equals 0. Remember, in order to solve these by factoring, we need them to equal 0. In order to use that fact that 2 things multiplied together equals 0, it means each part must equal 0. So our first step here is we want it to equal 0. We want to get this side equal to 0. That means I need to cancel the 4 and cancel the minus x. In order to cancel the 4, I need to subtract 4 on both sides. I'm going to subtract the 4 from the 4, and then on this other side of the equation, I'm going to subtract the 4 from the number. So minus 20 minus 4. You can do this in 2 separate steps, so you can do that, figure out what it equals, and then address that minus x. I'm going to do it all together in 1 step, though. If I also know I want to cancel out that minus x, I would do that by doing the opposite, by adding an x on both sides. I'm going to add the x to that minus x, and then over here I'm going to add the x to that minus 11x. So that's going to be where I add my x. Like I said, if this looks weird to you, you can do it in 2 separate steps, or you can do it all together. When you do this, on this right side here, 4 minus 4 cancels out, negative x plus x cancels out, and we are left with that 0 that we wanted. On this left side of the equation, that x squared is going to drop down. That minus 11x plus x gives us minus 10x. And then this last part here, negative 20 minus 4, gives us minus 24. Once you have done that, now it's just like the other ones we've done. We've got a quadratic equation equal to 0. I'm going to have you go ahead, pause the video, and see if you can finish solving this quadratic equation. All right, so because it's a quadratic equation, that means it's going to factor into 2 sets of parentheses. When you go to factor, because there's no coefficient in front of x squared, there's no number here, we know it's going to be x times x. And then for them to multiply to a 24 and combine to 10, it's going to be a 12 and a 2. That 12 is going to be negative, and the 2 will be positive to combine to give you that negative 10. The next part would be setting each one of those parentheses equal to 0. When you set this first one equal to 0, it gives you x equals 12. When you set the second one equal to 0, it gives you x equals negative 2. And so your final answer would be x equals 12 or negative 2. So this one here was my example. I'm going to have you go ahead, pause the video, and try this one here. It's a little crazy. How about this? Pause the video, and we know our goal is to set it equal to 0. Just do that first. Pause the video and set this equation equal to 0. Okay. In order to set it equal to 0 means I want to subtract 25. I need to get rid of the 25 there. The problem is I can't subtract 25 from this because it's in parentheses. Before I'm able to do that, I need to multiply this out to get something like this. Then I could subtract my 25. Now this goes back to Algebra 1a, our unit on polynomials. X minus 4 squared, what does that mean? Well, x minus 4 squared means you're taking this and multiplying it by itself. That's what squared means. So it means we want to do x minus 4 times, times x minus 4. When you write it like this, it's easier to see what math you need to do. The biggest mistake students make is they do x squared is x squared, 4 squared is 16, and you're done. But here, notice you've got to do all of this distributing. You've got to do x times x times the minus 4 times x, and negative 4 times negative 4. Once you do all of that, you are left with x squared minus 8x, and then negative 4 times negative 4, which gives you 16. You would get negative 4x, which combine to give you negative 8x. So we get all of that equal to 25. Now that you've multiplied all that out, now you could go in and subtract that 25 on both sides. When you subtract 25 from the 16, it leaves you with a negative 9. So we get x squared minus 8x minus 9 equals 0. Now that we've set it equal to 0, you can go ahead, pause the video, and finish solving this equation for x. All right, when you finish solving this here, it would factor as x minus 9 and then x plus 1 equals 0. So your final answer would be x equals 9 or x equals negative 1. If you were to check those up here in this equation, we didn't check this one, but if you were to check this one, we said x equals 9. Well, if you put 9 here, 9 minus 4 gives you 5, and 5 squared does equal 25. The other answer we said, I should write these down, we said x could equal 9 or x could equal negative 1. If you substitute negative 1 right here, negative 1 times, not times, negative 1 minus 4 gives you negative 5, and negative 5 squared gives you 25. There's one last part to this lesson, and it addresses a common mistake students make, and it's the difference between factoring something and solving something. When you are factoring something, what does that word factor mean? We use it a lot, but I want to review what it means. To factor something means to rewrite something as a multiplication problem. So when we are factoring things, that means I am changing it to look like multiplication. And when it's a quadratic expression, it means I'm changing it to multiplying two binomials, two sets of parentheses. If you're factoring it with GCF, it's the same idea. You're just changing it to look like multiplication where you've got one thing out in front times what's in parentheses. But factoring means changing it to look like multiplication. So when we factor something, we're just saying, okay, I know x times x gives us the x squared. We're looking for a pair of numbers that multiply to 10 that combine to 7. So that's 2 and 5. And then here they both would be positive. If you were factoring something, this here is your final answer. Factoring means changing it to look like multiplication, and I've done that. Here's my expression. I've changed it to look like multiplication. The difference between this and this problem here is solving means you're actually figuring out what x equals. And notice the difference between these two things here. This is not an equation. It's an expression. I don't know what this equals. I can't solve something if I don't know what it equals. Here, this is an equation. I'm telling you all of this equals 0. And when you're solving something, you are telling me what x equals. The reason I want to talk about the difference between these two is because when students start to see how you solve quadratic equations, they try doing that for everything. So I might ask you to factor something, and they try to say what x equals, but we can't do that if it's not an equation. That's not what factoring means. Factoring just means changing it to multiplication. What we're doing today is solving. Solving starts by factoring. So I would start off by doing the same thing here and say x plus 2 times x plus 5 equals 0. But then to solve, we're using that factoring to help us figure out what x equals. And so here I would set each part equal to 0. When you say that x plus 2 equals 0, that means x equals negative 2. And then when you say x plus 5 equals 0, that means x equals negative 5. And so to solve, you would get this answer here. It's a big difference between these two that I just wanted to talk about to make sure we understand the difference. That is everything I've got for you guys. Thanks so much for watching. Hopefully you're feeling really excited about solving quadratic equations, feeling good about it. I think they're fun to solve. Please reach out to us, though, if you are not feeling all the joy I feel for quadratic equations. We are here to help you all. You just have to ask. Thanks so much for watching, though. See y'all later. Bye.